Hi, I'm Bobbi, an analyst here at One Energy. Welcome to today's Science Short. If you haven't yet, be sure to check out the previous Science Short where Patrick did an amazing job explaining pulleys. Today, we'll be talking about another simple machine in the Simple Machine series, so put on your thinking caps and get ready to put in some effort, because we're leaping right into the wonderful world of levers. Like pulleys, levers also help with lifting loads. A lever is a simple machine made of a rigid beam with pivots on a point called the fulcrum. When you push down on one end of the beam, you apply effort or input force on the beam. The beam pivots on the fulcrum and produces the output force that lifts the load upward using torque. Torque is the amount of force required to cause an object to rotate around its axis or a pivot point. So, if a load is placed on the end of the beam, the effort is applied to the other end of the beam. Like the other simple machines we've previously discussed, a lever makes our work easier by increasing the input force and changing its direction. In a way, a lever provides a mechanical advantage. Remember, mechanical advantage refers to how much a simple machine multiplies the input force or effort. If you need more of a refresher, check out Carly's episode on a simple machine where she discusses the concept of mechanical advantage. Now that we understand what a lever is and how it works, let's take a look at the different types of levers and some real-life examples of each. The classification of levers is based upon the relative positions of the effort, fulcrum, and the load. There are three types of classes of levers: first class, second class, and third class. First class. This class of levers has the fulcrum located between the load and the effort. If the distance between the fulcrum and the load is less than the distance between the fulcrum and the effort, less effort is required to move the load over a short distance. If the opposite is true, more effort is required to move the load over a large distance. Can you think of any first-class levers that you might have seen around? How about a crowbar or a seesaw or even a simple pair of scissors? Second class. This type of lever has the load between the effort and the fulcrum. If the load is closer to the fulcrum than the effort, less effort is required to move the load and vice versa. Can you think of an example for a second class lever? Bottle openers and wheelbarrows are two great examples. Third class. The third class of lever has the effort located between the load and the fulcrum. And you may have guessed it by now, less effort is required to move the load if the effort is closer to the fulcrum. These levers are used when the precise movements are required. If you play tennis or baseball, then you have used these levers in a form of a tennis racket or a baseball bat. I hope today's episode helped you understand the concept of levers. Keep an eye out and see if you can spot any examples of levers as you go about your day. Thanks for watching, and be sure to subscribe to our YouTube channel, and remember, challenge everything.